critical requirement of any temperature uniformity survey is positioning the thermocouples in the furnace repeatably and reporting their location accurately in the survey report itself. In the application photograph on the slide in front of us now, you can see the frame whereby the thermocouples are at the 8 coordinates of that frame and in the center of the frame to give a 9-point survey, which is very typical. In the software, you can see we can create a schematic or a line drawing of the frame and showing exactly where the thermocouples are located with a description of the location on the frame. This is a TUS frame library file, which then can be retained within the software and used for future reference for future TUSs. Different frames can be set up and documented depending on the TUS that you are performing. In the software, if we access the TUS frame library file, there's a dialog in which you can set up from a default library set of files different shapes of frame, including, as you can see here, a cylindrical TUS frame, which would be used typically for a pit furnace. The thermocouples that are used in the TUS are then the markers or little coordinates are dragged to the coordinates on the frame to show you where the thermocouples are positioned. Obviously, this is important to determine where each thermocouple is in relation to the furnace void, which you're actually physically measuring. In most cases, we will use a 3-dimensional frame, but it may be possible even that you're going to create a 2-dimensional frame using the plane method, which is very typical for conveyorized furnaces where you don't need to have 3 dimensions to monitor the actual working zone of the furnace that's being used. Typically, the frame itself will have thermocouples which may be exposed, but you can also use heat sinks as long as you comply with the requirements of the AMS 2750 and CQI 9 standards. You may want to take photographs of that and include that for your frame. The line drawings is one option for creating a TUS frame, but you can also create your own customized image, maybe from a JPEG of a camera file, and you can annotate to give additional information which will be helpful with the TUS, including maybe even the working zone dimensions of the frame and survey that you are performing. What I would like to show you next is how to set up a TUS frame file in the Thermal View Survey software. For the active TUS run you can see on the screen at the moment, I can see the TUS frame information by going to the top right hand corner of the software screen to the thermocouple icon and clicking on it, and it then will show me the TUS frame file that is currently associated with that run, with 9 thermocouple positions on a physical 3-dimensional frame and with the text file to describe exactly where those thermocouples are positioned. To set up a new frame though, all I need to do is simply go to the settings library file and select TUS frame. To create a new file, I would simply go to the pull down menu for the file name, go to the very top, and you'll notice that there is a heading add new. So select that, and this will allow me to create a brand new Virgin TUS frame details file. I'm going to call it TUS frame new. One thing I have to select is the data logger that was used for the actual TUS itself, which would designate how many thermocouples are being used, 6, 10, 20, or a merge logger. I'm going to choose 10 because that's what I use for this individual TUS run. Click OK. I now have an empty dialog which allows me to build the visual representation of the TUS frame. I have 10 thermocouples active. I know that I used 9 for my TUS, so I'm simply going to turn the 10th thermocouple off. So I've got now 9 active thermocouples I'm going to need to position on the frame. What I need to do next is to select an image to represent the frame. The software comes with a few library files which are representative of simple 3-dimensional frames. So I'm going to pick this one here. You could, though, create your own file or even have a photograph like you see here for the TUS frame for the plane method. Whichever is easier for you. As long as it's a simple JPEG, that would work fine for the software. So if I click open, the frame image now allows me to position the thermocouple labels on the coordinates of the frame to show exactly where they are. And I can then describe with a text string the location of those thermocouples. So probe 1, for instance, thermocouple number 1 is the rear of the furnace. So it's furnace, rear, top, left. I could add notes. So furnace type, dimensions, etc., etc. Once I've filled in all the information I need for my TUS frame, I simply press the finish button, which acts as a save option. That would then save that file in the library. To retrieve the frame for the run, I simply go back to the TUS frames settings function and select the file that I've just created. And to apply it to the TUS, as is conventional for the software, I would then simply press the Apply to Current Survey button. If I then go to the thermocouple, you can see there that the file has been updated and all the information is correct for the file I've set up. Obviously, this isn't complete, but if I was to complete the job, that would all be present showing the data, and that would then be represented in the full report, the printed report, as documentary evidence of where the thermocouples were located.